I'm Anil Kumar sharing with you a test question on derivatives. The question here is, sketch the graph of f of x equals to absolute value of x squared minus 4 and its derivative. So let us first sketch the function given to us and then we'll sketch its derivative. Now let me write down the function here. F of x is equal to absolute value of x squared minus 4. So that is a parabola x squared minus 4, which I could sketch as like this. So what I've done here is I've sketched inside function. Let me call this as g of x, which is x squared minus 4, right? Now when we say absolute value, it means that we are going to keep everything which is positive as positive. That is, this portion remains same. Do you see that? However, that portion which was negative flips. So we get our sketch. We could actually define this function now as a 3p's function. Now obviously x squared minus 4 is 0 at plus minus 2. So I'll write minus 2 here and plus 2 here. And if I write 0 here, I get minus 4. So that positive value will be 4 here, negative value in the original graph was like this. So what we have is sketch for f of x. So everything positive. You get it? So that is the first part. Now we'll sketch the derivative of f of x. So let me draw some guidelines to help me out. Is the function differentiable at plus minus 2? Can you answer that question? These are like corners. Clearly, the function is not differentiable at plus minus 2, right? So that is important to understand. Okay. Now, based on this function which you have drawn, I could actually write this as 3p's function. So I say that this function is same as x squared minus 4 when x is less than minus 2, right? And it is equal to negative value of x squared minus 4 when x is, you can include minus 2's in this, right? When x, I should write like this. X is greater than minus 2 and less than 2, right? So we'll just include plus and minus 2 in this portion. Okay. In the last one here is x squared, same function minus 4 when x is greater than 2. Is that okay? So that gives you the function graph which we have drawn. Now, if you have to find the derivative, we could find these three individual derivatives in the portions, right? So we get f dash of x as equal to. So the derivative of this function is 2x, right? So we have derivative as 2x when x is less than minus 2. Now here, we know that at plus minus 2, the function is not differentiable. Actually, I should have written 3 bars here. Okay, so the function is not differentiable at x equals to plus minus 2, right? You have a corner here. The reason is that if I find a derivative on this side, you get negative. From this side, it's positive. We don't know which one is right, correct? So there's an ambiguity at these 2 points. That's the reason. But as you know from differentiability, that it is not differentiable at cusp and corners. Okay. So that means we have to find derivative of this. It becomes what? So it becomes like it is minus of this, so it is minus 2x when x is greater than minus 2 and less than 2. Since at plus minus 2 it is not differentiable, right? And the last portion here is derivative of this is again 2x when x is greater than 2. Perfect. Now you can easily draw the derivative function also. So we have when x is negative 2, right? When x is negative 2, if I substitute negative 2 here, we get negative 4. Let us say this is negative 4 for us. Negative 4 is not included. Now, so this is at negative 2. So if I write negative 3, so at negative 3, it becomes negative 6. So it kind of goes down, correct? So like this. Perfect. Let's go to the last wing here. Positive 2. 2 times 2 is 4, so it will be plus 4. Add 2, not including 2, with a slope of 2. So it is kind of going like this. Do you see that? Now in between, it is negative. So if I substitute negative 2 here, then what do I get? I get positive 4. Correct? I get positive 4. So in this portion, it is positive 4. And if I substitute 2 here, I get negative 2. Do you see that? So my function, at 0, it is 0. Perfect? So it's kind of like that. Do you see that? So that becomes the derivative of this function, and clearly at minus 2. If you approach from left side, the limit is the derivative is minus 4. On the right side it's different. So in this corners, it is not differentiable. So I hope you understand now. Whenever we have to find derivative of a piecewise function, we have to break it up. Whenever you want to find derivative of an absolute function, we have to break it up into pieces and then find its derivative. That's the whole exercise. I hope you appreciate it. Feel free to share your comments and views. If you like and subscribe, that'd be great. Thank you and all the best.